Okay, I'm going to go over periodic trends with you today. The first thing I'm going to do is label the groups or families. Those are the columns. They have similar characteristics. Some of them have their own name. So I'm just going to turn this first one, these are called the alkali. These are the alkaline. The center part, these are called your transition metals. Then this last column over here, these are called your noble gases. And then this group right here, group 17, this group right here, these are going to be called your halogens. So that's pretty much it for the names. And notice that I said that these are metals. I didn't really say it over here because the dividing area for metals and nonmetals is this stair step down the periodic table. So these are going to be called your metalloids. So I'm just going to write that up here. The stair step is called metalloids. That divides your metals from your nonmetals, and they have properties of both. Okay. Next thing I want to talk about are valence electrons. Those are your outer electrons. Those are what is involved in bonding. You're going to notice for electron I write E negative. That's just a symbol for electrons. Okay, and they have trends that go along with the groups or families. Remember, those are your columns that go up and down. Periods are left to right. They do not have similar characteristics, only the groups and families. So, if we look at the first column, these all have one valence electron. Okay, second column has two valence electrons. We're going to skip the transition elements. We're going to go to group 13. Group 13 has 3 valence electrons, 14 has 4, 15 has 5, 16 has 6, 17 has 7, and 18 has 8 valence electrons. Okay, so 8 is the magic number. It's called the octet rule, and that's what everything wants to get to be stable. So your noble gases are stable. They don't need to bond with anything because they have 8 valence electrons, so they do not form any kind of compounds. You will never see them bonded with something else. 7, the ones that have 7 are really close to being 8, so they're really, really violent trying to get to 8 to be stable. These are your halogens. Halogens are going to be the most reactive nonmetals that we have on the periodic table. And then the most reactive metals are going to be your alkali metals over here on the first column. Because they have one valence electron, that means that everything is trying to take that one valence electron to become stable. So they lose that one valence electron easier. It's easier to take one electron than it is 2 or 3. Alright, so that's valence electrons. Next we have a couple of trends that I'm just going to draw arrows to show how it increases. First is atomic radius. If you go down the periodic table, top to bottom, and you go, I'm just going to draw right through here, right to left, your atomic radius is going to increase. And right here too. So your atomic radius is increasing, going top to bottom, right to left. So francium is going to be your largest atom. It has the largest atomic radius. Okay, so these over here would be the ones with the smaller because it's at the opposite end of francium over here. Things that increase going left to right, bottom to top. So if we go left to right, bottom to top, the increases are going to be something called ionization energy. That's just the energy that it takes to make an ion. And electronegativity. Okay, and electronegativity is just how electronegative or electropositive something is. We'll write that in here. So this is ionization energy and electronegativity. So they increase going up toward this top corner. We have a tendency to leave noble gases, hydrogen and helium out of things because they don't necessarily fit into all of the trends. So these would be your more electronegative elements over here, these nonmetals. Right now you can see that the nonmetals are kind of green. Halogen has its own name for this column. Noble gases have their own name. These other ones are just kind of named according to whatever the first element is. So it'll be like the carbon group, the nitrogen group, the oxygen group. But the reason they don't necessarily have a name is because they have metals and nonmetals in them because they're right along the metalloids, so they don't fit into the trends or have similar characteristics. Okay, the next thing I'm going to go over are charges. And the charges are going to be used when we start bonding things together. So charges have trends that go along with the groups. So this first group has a positive 1 charge. Okay. Second group has a positive 2 charge. We're going to skip these. Okay. Group 13 has a positive 3 charge. So that would include aluminum, gallium, indium, these in this purple box right here. Those are going to have a positive 3 charge. That does not include boron, so it would just be these purple ones in here. Boron's actually a non-metal, so it doesn't fall into that charge. Okay, so that's pretty much it for the positive 3 charge. Some of these down here can have a positive 4 charge, but we're not really going to get into those. So germanium, tin, and lead can have a positive 4 charge. Alright, if we go over to the halogens, remember we kind of skip out on noble gases for everything, but if we go to the halogens, it does have a negative 1 charge. So that means that everything in this entire group has a negative 1 charge. And then if we go over here to the oxygen group, those all have a negative 2 charge, and I'm only referring to the ones that are in the green, not this purple one, because that becomes a metal. And then these are going to have a negative 3 charge. And once again, I'm only referring to the stuff in green, not the purple ones that are in this column. Okay. So that's the charges. Notice that the metals have positive charges. Nonmetals have negative charges. Positive charge is called a cation. And always remember that the T looks like a positive. If it has a negative charge, it's called an anion. Those have negative charges. So cations are your metals, anions are your nonmetals. Transition metals do have positive charges, but they can have multiple charges. So that means that they have to be represented another way, not with a trend. So when we start doing bonding, you will see that it'll have a Roman numeral after it, and that means that's what its positive charge is. So if it shows a Roman numeral 3, then it has a 3 positive charge.